cloud architecture. Means there are different kind of services we saw, like fault tolerance, the load balancing, the traffic management, and VM creation, deployment, security. So how they are managing means internally they are doing it, right? So we'll be covering some of the architecture. We are not going to cover every possible architecture in the cloud. Some of the architecture we will see in the virtualization, and some of this architecture are used in the virtualization as well. So some important architecture we will see. There are too many of them, and most of these architecture are very basic architecture. They are available into the most cloud service provider. And there is two architecture, the hypervisor and bare metal is little advanced architecture. And there are many task specific architecture is there. So in cloud, why different kind of architecture came? So depending on, there are too many types of companies are there. Different companies have different kind of scenarios, and with to handle different types of scenarios, there are certain scenario which is common to most. There are certain scenarios specific to a particular kind of domain or type of company or hardware in the background. So over the time, different solution has come up, and cloud service provider are coming up with different architecture. There are many more architecture is there, but we will cover this much in our course. So we had done colloquium on load balancing. That is basically the workload distribution, how they do. So what in cloud, what happened if you are using only one virtual machine? Then practically no load is there to manage. If more than one virtual machine or more services is there on the cloud, then the loads are different. So whenever different type of load comes, a shortage of IT resource will happen. And shortage of an IT resource will happen. There is auto scaling option and scaling logic based scaling options are there in the cloud. So in that time, the load balancer will try to distribute the load evenly. So that is a basic rule. A load balancer can have a different rule, but they will try to, let's say we have many cloud service consumer and they are trying to access to the cloud. So the first interface is a load balancer, and this load balancer task is to actually distribute whatever load coming evenly to the different IT resources. So this type of architecture can be used in audit monitoring. Like you have too many cloud consumers, and the load balancer will receive this request for services, and then it is going to distribute the load. There can be more than 2, 5, 6, 100,000. Same situation of workload distribution can appear for audit monitoring, can appear for cloud usage monitoring, hypervisor. We will be studying in the virtualization. So for this kind of task, workload distribution architecture can be a part of this. So this is a very basic that load come and very simple to understand. I distribute it. 100 load came, I distribute 50 to cloud service A and 50 to cloud service A. The next is a resource pooling architecture. So what in this does that there are one or more resource pool they create, right? And so they keep in side, like if this resource is needed, we will just provide the resources. So many of these resources are identical, like when the cloud also giving pay-per-use model, or whenever you need nowadays, a serverless computing is there, where they create in the background the resource pool, and whenever is needed, they are being given to it. So, to example of resource pool can be the physical server pool. So that means there are physical servers. There are multiple physical servers. They will keep in a pool. When demand comes, we will provide. Similarly, virtual server pool, they can create, like virtual server, they can create of Windows OS type, or the Ubuntu operating system based VMs. And this, the common kind of VM required by the industry, if industry is going for on demand, like if any of you, do you have idea of Google Colab? Anyone know what Google Colab is? Any idea about Google Colab? Okay, so Google Colab is a kind of service. What was happening means how Google Cloud platform came up. So when Google has a lot of servers and immense amount of computing power, few 100,000 servers they have, and which they are keeping it to manage provide to their own Google services. Like Google is an umbrella, like A, B, C to Z, right? Google now new name is A to Z company. So they have many services, and they were keeping a lot of hardware as a backup. And like, for example, Google Map. So when Google Map people are using it, when high traffic is there, more people are using Google Map. And that time they need more compute virtual server in the background, virtual machine in the background to serve their people who are using it. Now, what they found that when people, not much load is there, so those virtual machines are remaining idle. What Google did, okay, let's utilize it. Let give it the virtual machine free for people to use it. So it is a compute system primarily used by machine learning people who are working on data science. Tons of students are using Google Colab, and Google Colab Basic is free. And in that you can run your Jupyter notebook, and it comes with GPU and virtual machine, the CPU and GPU and certain RAM for free, and it can be integrated with your Google Drive, and it can run on the Google platform. So similar thing you can do also on Azure, but I'm just giving example. So so that is called a virtual server pool. So similar type of virtual machine they have created, and on demand people can use it because it is remaining idle. So they are providing the service for free. But from this year, they started providing this service for charges now, because more and more people are using it. So less and less number of virtual machines are available for easy to use. So they came up with Google Colab Pro. In that, they charge around $10 per month, and with $10 per month, you can use the Google Colab. If you do not have GPU's power or GPU, and you want to run data science application which require machine learning and GPU capability, then a lot of students are using Google Colab Pro version. So that is an example of virtual server pool. So after giving for free, now they are paying it. Now, if you want more power or more longer duration, in Google Colab Pro, the virtual machines you will be available for 8 to 10 hours, and most of the program can run in 8 to 10 hours. If it is a very compute intensive machine learning where training might take 3 days to a month, then the Google Colab Pro may not be useful. You need a larger, more dedicated service. So that is how they create a virtual server pool. And similarly, they create a storage pool, like Dropbox do create a storage pool, or Azure also have a storage pool, depending on the client who wants dynamic storage solution. They do not want to take a dedicated storage. They want a dynamic storage as per the business need. The storage will be provided to them. So Azure keep in the background, or different cloud server provider, they can keep the different type of storage, like you want SSD type, or you want a SATA type, you want what type of and what speed of storage. So they create different kind of pool, and when demand comes, it can be provided. Similarly, the virtual network pool, the network pools are there. CPU pool, so in the CPU pool, the smallest unit will be one core. So like if I have a 32 core system, so 32 core, 31 core, they will use it as a CPU pool. One core will be there for its OS. So 31 CPU core will be kept as a CPU pool. So one core will be given, and someone wants 4 core, then 4 will be assigned. Similarly, the memory pool, like random access memory, RAM, they can create a pool. So here there is an example where this is a nested pool, a virtual server, which in the top has 4 virtual server pool, like 4 VMs, and 6 CPU pool and memory pool of 12 GB RAM, or 12 memory pool. So in this, A1 has 224 and this one has 248. So together it has A has a service of 4, 6, and 12. In terms of this type of resource pooling architecture is also used for audit monitoring, cloud usage monitoring, hypervisor, and many other services. So as you see, that similar looking virtual server they are creating, similar type of CPU pool they are creating, similar type of memory pool. So this is one example of nested type of resource pooling architecture. Next comes the dynamic scalability architecture, means architecture which can provide dynamically. Like cloud, we go for scalability and dynamic allocation. So in this case, how they do it, if we say, okay, when the 50% or 80% workload is there on one virtual machine, so trigger to create a new virtual machine. So that's, we can use this dynamic scalability architecture based on that kind of trigger, that more IT resource allocation can be given or IT resource allocation can be reduced. So if we are going for a dynamic horizontal scaling, means we are adding resource after resource horizontally, that is, can be done both increase scale out and decrease scaling for handling different kind of workload. We can also have the dynamic vertical scaling, as we saw in our last lecture, that on Friday, that scaling are two types, horizontal and vertical. In a vertical scaling, the reboot will be needed, because in vertical scaling, the type of resource like CPU or RAM, especially CPU, more powerful CPUs are needed. They ask for more powerful, more gigahertz power system. So for that, or a different kind of operating system, for that reboot will be needed. Then there are dynamic allocation, relocation, means if one VM is like situation arises of some VM is faulty, not responding, then, or they are asking for vertical scaling. So dynamically a relocation can be done from one VM to another VM, or one resource to another resource. Like we ask for a 10 Gbps network connection, and now the need is 100 Gbps network connection. So dynamic relocation of IT resources can also be done using this dynamic scalability architecture. So how does it does? One type of thing is that the cloud service consumer, which is one, asking for resource request to cloud service, and this is automatic scale listener, and it is going to decide what capacity it has, and based on if the capacity increase, give more more services. So this is a very simple one, and if we go for a bit more complex, there are many types of dynamic scalability architecture. So like now the cloud consumers are asking for requests, and this automatic scale listeners are there. Now this automatic scale listener number 4 find that it's overloaded with a request, then the 5 can just say that which are the new services can be used. So dynamically things can scale or scale out, and within that some decision maker can be there. These also are used for cloud usage monitor, hypervisor, pay per use monitor. This kind of architecture is used. Another example of dynamic scalability where resource replication is required. So there can be resource application that can automatically decide, like if so, let's say some fault happened and disaster recovery is kept. So they have to keep replicating the resources all the time so that the fault tolerance or disaster recovery can be done. So this, depending on different scenario, you can also design this kind of architecture. And this particular topic is a part of syllabus for written examination. This is not Azure. So please pay focus for this section. There are like storage are there, and storage has a typical problem. They all fail, whether we have SSD or SATA or any other storage devices. They have different percentage of failure rate. 3 to 5% is for SATA and 1% is for SSD. So when what happens for storage fail, right? Storage can fail, and that can cause disruption. Like if we take one storage and we keep our application on one storage, and if that storage fails, then the whole application is not going to work. Or let's say my VM was running on and using one storage. We have many VMs, and that particular VM serving to a particular user. Like I am using a Google map, and you all are using a Google map. Let's say the Google map which I am using, in the back, it is served by the virtual machine, and that is accessing certain data, right? That is coming from a storage. Now that storage got a failure. So my service will be affected. So what they are going to do? So this kind of situation can happen because of hacking, because of network connectivity failure, either at the cloud side or at the user side. Or let's say we are accessing while moving, that time our nearest mobile tower, the connection is relocating from one to another. Yes, this slides of cloud computing book. Yeah, I got this book picture from the book. Earlier, I was making the picture myself. Later on, I come to know that this book, somewhere they have written that the images are available. So yesterday only I able to know this. So I am using this, and the link, you can go here and you can download this picture. Okay, and this all numbered as per the figure number in the book given. So if it is 11.1, then the figure number in the book is 11.1. So if you download it will be figure number 11.1. So how they do it, they have a storage service gateway, which can automatically redirect the consumer request if the cloud service storage in the background fail and it has been relocated to another. So these are two storage. One is a main, other one is a backup, or there can be many backup. And if this storage fail, so all the VM who supposed to get access to this and get service will not be able to do. This is sensed by the storage service gateway, which will automatically direct the service to another storage, and then the task can be done. Right? Simple. So you can see the figure which I have created a bit very simple and not so good. So this is a cloud busting architecture, as we were saying, looking like private cloud is there, public cloud is there, hybrid cloud is there. So this particular cloud busting architecture is a part of hybrid cloud. So what it happens that people who are running a company, they have a lot of them has already dedicated servers and network. But over the time, their business capacity is changing, and nowadays companies are not investing in their own on-premise hardware and server system. So they want to utilize their current system, as well as if the load comes more, they want to go to the cloud. So the cloud busting architecture is actually able to handle this type of request. So when this is a on-premise network where many users are there, and here if the listener and automatic scale listener understand that the load is going beyond the capacity of my services, then it will directly recruit the cloud service and get the connection and shift the load to the cloud, and that's how it can increase the capacity. So that's why it's a burst out. So that is the reason cloud busting architecture is there. So it helps in triggering the dynamic scaling. And when the load is not there, then the services will be served by the on-premise thing. So you can see when the load goes more in on-premise, then the service will be directed to the cloud. Now this one is, this architecture is a little advanced architecture, and this is called hypervisor clustering architecture. So in terms of hypervisors are used actually to create virtualization. It's a software. Hypervisor is a software. It is used to create a virtualization. Now, hypervisor can be of two types. One is called type 1, other one is called type 2. We will know more about the hypervisor in virtualization section. For architecture, cloud computing architecture purpose, what happened? Let's say we have this physical server and we put a hypervisor on it. And then this hypervisor is actually helping us to create the virtual machine, which we call it a virtual server, right? Now, this is an integral part of the cloud, right? What if the hypervisor fails? Means on the very premise, which is actually doing, so it's like my brain is doing every activity. What if my brain fails? So if hypervisor fail, then all the VMs will be cut off from the server. No service will be given. So hypervisor is basically a software. It can come with its own OS, or if it is type 2, if it is type 1, then hypervisor is completely installed on the hardware. Means if it is installed on the installed software or operating system, like say we have a physical server, and on which I installed Windows Server, and on top of it I install hypervisor, then hypervisor will help me virtualization of my physical server. That is called one type of hypervisor. Other than that, I get completely hardware which only have the boot OS. On top of it, I'm installing the hypervisor. So without installing any operating system like Windows and Linux or any other OS, so we can also put an hypervisor. That hypervisor will come with its own OS, and then it can also help in virtualization. So if this hypervisor fails, then the task will not be done. So to handle this kind of situation also, because in the background, in the cloud, there are servers are there, and servers do fail. The failure rate is out of 80,000, there will be at any point of time, any day, 3 to 4 server are going to fail in every cloud services. 3 to 4 server are going to be failed and need to be replaced in every cloud service provider. And failure reason can be some simple or can be a completely hardware failure. So to handle this, they have created the hypervising clustering architecture. So they have created a multiple hypervisor backup, and they sense each other whether they are working or not, right? And this architecture can be used to handle the situation where the hypervisor is failing. The next one is, which is means how they know. Like they have this VIM, virtual instance manager. It keeps track of different server, and it tries to measure whether they're alive. And this is done at the schedule, algorithmic schedule is there. Okay, I'm going to sense every 5 minutes or 10 minutes or 1 hour. And this sensing is called heartbeat. It is a system level message, basically send ping kind of thing, like pinging, it is active, or different type of message also can be there that I am active, my OS is okay, my network is working okay, or my battery level is this level. So this different kind of message can be there. It is a system level message, which is exchanged between the hypervisor and a virtual server. So between the virtual server also can be exchanged, and also between the physical hypervisor can be exchanged, and between the hypervisor and the virtual instance manager. So that actually helps them understand whether a particular service is working or not, and whether we need to shift the load to other places. Now, another type of hypervisor is called a bare metal hypervisor. So a bare metal or type 1 hypervisor, when it is directly installed on the server hardware, means we bought complete blank hardware. The CPU, the network, and the RAM and GPU, everything is there. It is a basic, nothing has been installed on it. And if on that, if we install the hypervisor, that type of hypervisor is known as bare metal hypervisor, and that can help in virtualization. But if we are installing the hypervisor, which is called hosted hypervisor, on an OS, means you can create your own laptop on which you work, and it has an OS. And if you put hypervisor on your own laptop, then you can create your laptop as a virtualization platform, and that hypervisor can help you. If you have a 4 CPU or 8 CPU, 8 core or 4 core with 12 GB RAM or 8 GB RAM laptop, you can have 4 to 5 VM on your own laptop, and you can host your, if you want to host anything which require 4 to 5 VM, any application, you can use your own laptop to create a virtualization environment without even paying to the cloud, and if you have a network access. And there are free hypervisors are there which can be installed to do that. So these are known as type 2 hypervisor. In this case, what happened, like they keep track of, in bare metal provisioning architecture, they will have a deployment system, they will have a discovery agent which is going to sense, because if you see that if you are installing directly on the server hardware, it doesn't comes with the operating system like Windows or Ubuntu or Linux. It does not come. So a lot of ability is not there. And usually a bare metal hypervisor is used by a single tenant, usually. It is not used by the multi-tenant. So in that case, quite many capabilities not there, but then they overcome the limitation, or actually that many has a requirement that we want bare metal, we don't want multi-tenant. That case, this kind of different provisions is there, which actually able to sense if failure, etc., and resource transferring, allocation, And there is a self-service portal which manages the information. So this is how it is done for bare metal provisioning architecture. So with this, today's lecture has been finished. It's quite early. Yeah. Any questions so far? Any question? We have something else also. We're gone. Not this. Yeah. Any question? There is a 2 slide is there. I will just show and then we can end today early. We can have early home. And is it okay? Any question you have? So no reply today class. Okay, so thank you who are replying. I feel that I'm getting the response. If you are interested to read more about the cloud architecture, I like the architecture topic. I can think more abstract way. What is connecting where, who is making connection to this, and what happened if this happened or that happened, or the flow within the software. That is my favorite area. So if you have that kind of interest, then you can read other architecture in the book as well, though they are not part of our course. But for your own knowledge, you are free to use it, read it. So there are 2 case studies I am going to give you today, and solution I will be discussing tomorrow in the Friday lecture. And tomorrow is the Friday lecture. After that, 3 weeks we don't have Friday lectures. So this particular topic is there, right? And you can have a look. This is related to the fundamental part 3, the module, different kind of services Azure is providing, and this kind of question will appear in your assignment 1. So have a look, and because these are a bit more, require more time and read. You can tomorrow we will know about Azure Data Lake Storage, and then you will have more idea about it. But you can have a look. I have uploaded this to the Canvas. So I hope it's clear. And if you have any question, by the way, we have Colloquium 4 to be submitted, and the workflow has been created. There is no Colloquium 3 report needed to be submitted, and the due date is next Wednesday. So please submit. So thank you. If you have no question,